Now, I want to discuss now solubility of the gases. Solubility of the gases in liquid as well as solubility of the solid in liquid. Now, what is the meaning of solubility? Solubility indicate for any component how much it is dissolved in a specified amount of solvent. That is called solubility. And solubility we can explain by giving different conditions. It depends upon the temperature, it depends upon the pressure, it also depends upon the nature of the solvent, it also depends upon the nature of the solute. The first, I want to explain solubility of solid solute in liquid solvent. Solid when dissolved in liquid. So that case, what factor affect the solubility? And different factor affect the solubility. That is, the temperature is one of the factor. Normally, at a particular temperature, the solvent has the maximum capacity to dissolve the solute, and we say it is a saturated solution. And if you increase the temperature, obviously for solid in liquid the solubility increases gradually, that is increases, but that is the optimum level. After that no solute is dissolved in a liquid, and situation is called supersaturated solutions. And if you further decrease the temperature, the solute particle that is separate out, that the process is called crystallizations. So what we learned here, in case of solid in liquid, if you increase the temperature, solubility increases. Similarly, if you take the gas, then what happens? Now remember, for solid, when dissolved in liquid, there is no effect of pressure on the solubility of the solid solute. But if you think about the solubility of gas in a liquid, solubility of gas in liquid, that means if you make a solution of gas in a liquid, that also depends upon many factors. The factors are like temperature, one factor, then another factor is pressure. These are the two main factors which decide the solubility of the gas in a liquid. The first factor, if you increase the temperature, then what happens? In this case, the reverse effect is found. That means if you increase the temperature of the solutions, then solubility of the gas decreases. And we can increase the solubility by lowering the temperature. And this is the best example when you prepare the cold drinks. So normally it was suggested that we have to keep the bottle in the cold temperature because maximum number of carbon dioxide can dissolve in the solutions. Similarly, pressure also plays important role. If you increase the pressure, the solubility of the gas in a liquid solvent, that is increases. And that also, there is some relation between the pressure as well as solubility of the gas. The maximum solubility we can get a particular pressure. And these two relation, that is two effect, that is temperature and pressure effect, that is nicely explained by a scientist. His name was Henry, and he proposed some law, and that give the quantitative relationship between the solubility of the gas with pressure as well as temperature. Now we have to discuss the Henry's law, and Henry's law is a very important law which explains the solubility of the gas in a particular solvent. So Henry's law, and what is the law? This law, if you define this law, it is coming like that: solubility of the gas is directly proportional to the external pressure over the liquid. If you think the solubility of gas is M and pressure is P, external pressure which is above the liquid, so P is directly proportional to M. That means solubility of the gas is directly proportional to the external pressure. If you increase the pressure, then solubility also increases. And another scientist, Dalton, also gives a similar law. Now, this law can be explained in different way, in better way. The solubility we can explain in terms of mole fraction. Solubility, if you think about the mole fraction, because mole fraction is number of moles present by the total number of moles, so that indicates the solubility of the gas. Mole fraction means more solubility. So this Henry's law can be explained nicely by this way. The mole fraction of the gas is directly proportional to the partial pressure of the gas over the liquid. Can I repeat this? The mole fraction of the gas is directly proportional to the partial pressure of the gas over the liquid. If you think, I am taking the component gas A and mole fraction of the gas I am again Xi. So as per the Henry's law, we can say that Pa, partial pressure of that A gas, is directly proportional to the mole fraction of the gas. So we can say that Pa equals some constant I am using Kh into mole fraction of the gas. So now Henry's law can be defined this way. Mole fraction of the gas is directly proportional to the partial pressure of the gas over the liquid. Now here I am writing one constant that is called Kh, and this Kh is called Henry constant. Henry constant. But remember, this Henry constant, that is different for different gases. And this constant has certain parameters also. That value of this constant, that is also changed with the temperature as well as pressure also. If you increase the temperature, the value of Henry constant also increases. And obviously, when the value of Henry constant increases, the solubility of the gas decreases. So what I am explaining now, if temperature increases, Kh value also increases. That means Henry constant increases and solubility of the gas decreases. If you increase the pressure, the value of Henry constant decreases and the solubility of gas increases. So this is the justification of the Henry constant. Normally, in case of nitrogen, in case of hydrogen, the Henry constant value will be high. Even helium has very high value, the solubility is less. Now, basically, we have to learn the different application of the Henry constant. One of the applications, when you prepare the cold drinks, preparation of the cold drinks bottle, number one. So when you prepare the cold drinks, so normally extra carbon dioxide is added in the bottle at the time of sealing the bottle. Because if you add extra carbon dioxide, that creates extra pressure, so solubility of carbon dioxide will be more in the cold drinks bottle. So that is one of the application of the Henry constant, Henry's law. Second, another important application of the Henry's law, that is scuba diver who drive in the deep sea. Normally, earlier they carry the normal gas air for their respiration. But problem was there, at high pressure under sea water, all the gases present in the air that dissolve, and when this diver come near to the surface, pressure is less, so that time what happening, the dissolved gas come out in the form of bubbles and that blockage the artery. And that time problem arises, sometime tremendous pain, sometimes some other medical problem arises, and that is dangerous for the life. So therefore, to avoid that bends, it is suggested that some inert gas, especially helium, whose percentage is near about 11%, that is added with the air, and the mixture is coming like that: 52.9% nitrogen, 11.5% helium, and rest is near about 32%, that is oxygen is used. So that case, when the drivers come out, the solubility of the gas is less, and that is not affect their problem, my health. So we can avoid the bends that way. So this is the important application of the Henry's law. So this is about the Henry's law. Okay, thank you.